So my name is Andy LiWang, and I am a professor at the University of California, Merced. We use nuclear magnetic resonance spectroscopy, or NMR, to study the mechanism of a cyanobacterial clock. As you know, what's cool about the cyanobacterial system is that you can reassemble it in a test tube, the proteins, the clock proteins inside a test tube, without any living cells. So by NMR, we're actually looking at the resonances of the spins inside these proteins. The cool thing about NMR is that because it is atomic resolution and because you can look at these proteins under native conditions in solution, under physiological conditions, that you can see how they would behave inside live cells, or at least a close approximation. NMR cannot compete at the size of these proteins. We cannot calculate the structures, determine the structures of these large proteins by NMR, unlike crystallography and cryo-EM. And so the niche for NMR is really looking at the way the proteins move and see how the individual side chains and backbone atoms of a protein move at different times of day. So right now, the input pathway and the output pathway to the cyanobacterial clock, I think, are still areas that are rich areas to explore. With regard to the oscillator, what we still don't know, even though now we have a set of high-resolution structures of the clock protein complexes, those are static, they're basically snapshots. So we don't really have a lot of information on how the clock moves. Right now, with those high-resolution structures in hand, what we want to do is we want to study the clock as it moves. I think those are the areas where we need to go into next.